Okay, class, welcome back to chapter 5, section 4. We're going to factor today, solve polynomial equations. So we're going to use a little bit of what you learned last chapter into this one. So let's do example number 1. We're going to factor, it says factor the polynomial completely. Basically just keep breaking it down till you can't factor it anymore. So first thing you always do when we say the word factor, hopefully you remember GCF every time we say factor. So if you look at this problem right here, the GCF, well, this is 1, this is 2, this is 15. There is no number GCF, but look at this, x cubed, x squared, and x. There's 3 x's, 2 x's, and 1 x here. So the most that they have, all three have in common, is just 1 x. So you pull it out. Here's your GCF. And x times x squared gives me x cubed, plus x times 2x gives me 2x squared, minus x times 15 gives me minus 15x. Now you always look at this and say, is it completely factored? Well, you know how to factor trinomials, so go ahead and do that. Factors of negative 15 that add up to positive 2. So what would those two factors be? Well, that would be positive 5 and negative 3. So positive 5 and negative 3 multiply to get negative 15, and they add to get positive 2. But don't forget about your GCF out front. This here is factored completely into 3 factors. 1, 2, 3. Alright, the second one here. Make sure you factor out a GCF, which is 2. And there's 5 y's here, there's 3 y's here, so there are 3 in common in both terms here. So that's why it's 2y cubed out front. Times 2y cubed times something gives me 2y to the 5th, which is y squared. Bring over to minus. 2y cubed times something gives me 18y cubed. That has to be 9. So this times this gives me this. This times this gives me this. And I'm set. But make sure that you're completely factored. Now this isn't completely factored. This becomes y minus 3, y plus 3. This is the difference of squares that we talked about last chapter here. So this is completely factored. 1, 2, 3 factors. Okay, in the last part of example 1, we factor this. Once again, GCF. You see 4 out of 4, 16, 16, and then you see z to the 4, z cubed, z squared. So there are 2 common in each of these. So that's why it's z squared here. Alright, now 4z squared times something. Z squared gives me 4z to the 4th. Minus 4z squared times something, which is 4, just z. Just multiply, and it has to give you this. Lastly, plus 4z squared times something gives me 16z squared. So it has to be 4, and that's all. So when you multiply, it has to give you the original. Next, you look to see if this factors right here, and it does. Factors of 4 that add up to negative 4. Well, that's minus 2 and minus 2. So you'd have z minus 2 times z minus 2, or z minus 2 squared. But still have your 4z squared out front. And there you go. Completely factored. Okay, for example number 2, we're going to factor again. Only this is the tricky part of today. Well, the sum or the difference of cubes. Now, you probably wouldn't have known how to factor this before because it's a sum. Usually you're used to a difference, right? So you might have left it alone. But if it's the sum of cubes, here's a cube, and 64 is actually a cube, which we're going to get to in a minute. Let me go back and let's take some notes on this. You need to know a couple formulas, which are right here. So you should take a moment, maybe pause the video, and take down these 3 things, or these few things right here. This right here is the sum of cubes. So if you have a cubed, something cubed plus something else cubed, you can factor this right here is factoring it into these two factors, one factor, two factors. Okay? So you just need to know what your A is and what your B is, and then you'll be able to plug it into the formula. But you have to memorize this formula. I'll tell you ahead of time, yes, you will see something like this on the quiz and test. Okay? Maybe one of these, maybe both of these things. So you have to figure out, is it a sum of cubes or is it a difference of cubes? Is it minus? Okay? As long as these things are cubes, you can factor into this right here. So let's use the above formulas to factor this guy right here. First thing I'd be thinking is, okay, here's a sum. So is it a sum of cubes? Well, yes, that's obviously a cube because x cubed. Then I'm thinking, is 125 a cube? Well, factor out 125. 25 times 5. So really this guy right here is 5 to the third power. So I'm going to rewrite them. X cubed, oops, plus 5 cubed. I write it like that so that I know what my A is and what my B is. So if I've memorized the formula, I just go back up here and say, okay, I know what A is. A is X and B is just 5. So let's plug it in the formula. A plus B. So X plus 5. There's my A plus B. And then we go up to here, A squared. So A is X squared minus AB up here. So minus A, which is X, I'll clean it up later, times B, which is 5. Lastly, plus B squared. So plus B, which is 5, squared. I just showed you all the work. Now just kind of clean up a little bit. X plus 5 is out front. And then x squared minus 5x plus, this becomes 25. And there you have it. You just factored a sum of two cubes. So you circle that and you're done. Okay, off to the side here, the next one, I have difference of cubes. Well, you won't notice it right away, but because 3 isn't a cube. But remember, the first thing you always think when you see factor is GCF. So off to the side, let's do it. Why did that happen? Here we go. GCF of this is 3. 3 and 24, 3. X to the 6 and nothing, so that's it. So pull out a 3 and there's my GCF. Now we have x to the 6th minus 3 times 8 gives me 24. Now, you may not think this is a cube. You have to look at 8 and say, is 8 a cube? Well, I'm going to rewrite it. Okay, off to the side, I'm going to put, okay, 3, and then my thing's not working too well today. What's going on? Let's go 3, parenthesis. Instead of x to the 6, that is a cube. All you have to do is say, okay, what makes it a cube? Well, x squared cubed is x to the 6. So you just have to check, is it a cube or not? So kind of play with it, see if it is. Minus, is 8 a cube? Well, yes, it is 2 to the third power. So what I have right now is a difference of cubes. All I need to know what is my A and what is my B. So as you can see, here's my A cubed, here's my B cubed. So let's use the formula up here, up above. Here we go. Let's change the color here. So let's put in the formula. The first thing is A minus B. What's going on? Okay. Notice A minus B, A minus B. Up here, A plus B cubed, A plus B goes first. These formulas are very, very similar, so please study them very well, because you'll mess it up if you just kind of know it. Ready? Let's put it in. 3 always goes out front here. Oh my goodness, this is gonna make me angry. Let's go back. 3 print. Oh my goodness. I might throw my computer out the window. Okay, try it again. There we go. 3. Now A minus B. So A is right here. B is right here. So A minus B. There you go. X squared minus 2 times up here A squared. So here's what I have to do. X squared is A. X squared is A. So A squared. There's A squared. Plus AB. Well, A is X squared. And B is here. 2. And then lastly, plus up here, B squared. So B is 2. And we square it. That's the hardest part. Remembering what to do, what is A and B, and plugging it in. The easy part, hopefully, is the simplifying. You get x squared minus 2, and then we got x squared squared, so x to the 4th plus, put these together, 2x squared, and then plus 4. There we go. We have now done a sum of cubes and a difference of cubes. We have factored them. Now I'm going to, off to a side note, that is not the same as last chapter when we did this, x plus 5 cubed. This is expanding this into something else, x cubed plus 3x squared, 5, so on, so on. Okay, that is something totally different. Okay, so look back at your notes for that. That and this are totally different. So be careful with that. I'm just telling you things that are to come. People mess that up. Alright, done with factoring sum and difference of cubes. Alright guys, try a couple examples for yourself. Look at number 1, try this, pause the video and try it. Okay, number 2, pause the video, try this one. Number 3, pause the video, try this one. And number 4, try that one. Okay, take a moment to check your answers to those 4 problems, and then we'll move on. Okay, the next type of example is factoring again, but by what we call grouping. It's the grouping method, so you want to label that somewhere, the grouping method. Now, notice that this is not a binomial, not a trinomial, but there are 4 terms right here. Since there are 4 terms, we are going to group them into 2's. Okay, how do you group them into 2's? Well, you could take the first 2 and the second 2, as long as they got something in common. Like, look at the first 2, x cubed and x squared. They got something in common. Look at the second group, 16 and 48. They got something in common. So step 1 is you're going to take these 2 and find the GCF, which is x squared. You're just going to factor it out of these 2. So that becomes x squared times x, minus x squared times 3. Out of the second part here, 16 and 48, you're going to pull out a 16, but since there's this minus 16, it makes it a little tricky, so you're going to pull out a minus 16 instead of just 16. Okay, times x, and be careful, minus 3. Alright, now, I pulled out GCF out of the first 2, pulled out GCF out of the second 2, and watch what happened. These 2 things inside parentheses are the same thing. So basically right now, that is your GCF. Like, this is common in both terms here. So if this is all one term, that's common. If that's all one term, That's common. So what we're going to do is we're going to pull that out. We're going to pull x minus 3 out. And all we're going to do is write whatever's left over. That's left over, and that's left over. X squared minus 16. So what you just did is factored by grouping, but if you paid close attention, we're actually not done yet. Many times you'll be done, but not this time. So step 1, pull out GCF out of these two, pull out GCF out of these two. There they are. Step 2, pull out this GCF. This is common in both, so we pulled it out to here. And then we wrote down whatever was left over inside the parentheses here. But be careful, sometimes these will go again. So x minus 3 cannot factor again, but this is a difference of squares. X minus 4, x plus 4. We completely factored this up here. If you FOILed, or if you multiply these three things together, you would get what you see above. Okay, example 4. We're going to factor polynomials again, but there's a different type of form up here, quadratic form. We'll get to that. Let's look at this right here. If I told you to factor this right here, step 1, look for GCF, which 16 and 81, there's not a GCF. You notice it's a difference. The next thing you think, is it a difference of squares? Is it a difference of cubes now? Now you know that. Well, I know it's not a cube. I mean, 4 power. The 4th power can't be a cube, so we're okay on cube. But is it a square? So what you have to look for, is this a difference of 2 squares? Well, I know 81 is a square. That's 9 squared. 16 is a square. That's 4 squared. And x to the 4th is a square. X squared squared. So all of this in the parenthesis right here, squared, gives me 16x to the 4th. So 16x to the 4th, this guy right here, is a square. It is 4x squared squared. Why did I write it like this? So that I know my A and my B. This is a difference of squares right here. All you're going to do now is use your A minus B, A plus B. So here we go. A is all of this right here, A squared, so A is 4x squared minus B, which is just 9. And then you got 4x squared plus 9. You look at these two again and say, do those factor? Well, this is the sum. Well, the only thing that can factor so far is the sum of cubes. 4 isn't a cube, x, none of these are cubes, so that's okay. So over here you have minus, so you're going to ask yourself, is this a difference of squares or difference of cubes? Well, I know it's not cubes, but look at this. 9 is a square, 4 is a square, x squared is a square. So this becomes 2x minus 3, 2x plus 3. If you factor this as a difference of squares, here it is. But then you still got 4x squared plus 9. And there you have it. Here is your final answer, all factored out. Alright, here's the other part of example 4. I just wanted to put it here for more room. So if it said factor, step 1, GCF, well, 2, 10, and 12, GCF is 2, x to the 8th, x to the 5th, x squared. The biggest that goes into all these is x squared. So pull that out of each term up here. So 2x squared times what? X to the 6th power plus 2 times 5 will give me the 10. X squared times x to the 3rd will give me x to the 5th. Lastly, 2 times 6 will give me the 12. X squared times nothing, 1 will give you x squared, so stop there. So we put out a GCF. And just by looking straight at this, you might think, well, that doesn't factor right there. But you got to be careful. This is called something called quadratic form. This is not a quadratic, but it has the form of a quadratic. Watch. I'm going to take x to the 6th and I'm going to make it look like a quadratic. Watch this. X to the 3rd squared. Isn't that right? X to the 3rd squared is x to the 6th, right? Plus 5. I'm just going to put this in parentheses. X to the 3rd. What you see above, I just put it in parentheses. That's okay. Plus 6. Excuse me. Now, look at this right here. X to the 3rd squared plus 5x to the 3rd plus 6. Watch what I'm going to do. Instead of x to the 3rd, I'm just going to take that out of there. I'm going to take out x to the 3rd. And off to the side, I'm going to do this. U equals x to the 3rd. Okay? Come on. U equals x to the 3rd power. Okay? I'm just going to do a little substituting right now. Instead of x to the 3rd, I just said x to the 3rd is u. So, watch what happens. U squared plus 5. Instead of x to the 3rd, I'm going to put u plus 6. Now, is that or is that not a quadratic now? Yes, it is. So here's what we're going to do. You're going to factor this quadratic. Star this problem because I know this is going to trip people up. Okay? All the little things we're doing here. So star this problem. If you have trouble, come see me. Let's factor u squared plus 5u plus 6. Factors of 6 that add up to 5. So u plus 3 and u plus 2. There you go. You just factored this. But u wasn't really u. What is u again? U is up here. U is really x cubed. So instead of u, I'm going to substitute back. I'm going to put x cubed plus 3. And instead of u, x cubed plus 2. But I'm missing the GCF that we had way up here. So you see x to the 6 plus 5x cubed plus 6 right up here? That actually factored. That guy factored to this right here. Okay? So I'm missing 2x squared out front. And there you have it, folks. This is how you factor something in what we call quadratic form. Okay? So, some things aren't quadratics, but you can make them look like quadratics. Okay? You can make them look like quadratics. So, we'll practice some more of those. Okay, let's take a couple minutes to practice some of these. So this first one has 4 terms and you are factoring. So whenever you think 4 terms factoring, you think group. You're going to group things together. So go ahead, pause the video, do this one. Okay, here's your answer for that. Alright, next one. Factor this one, pause the video. There's your answer for that. Next one. Factor this one, pause video. And here's your answer for that one. Alright, last question, example 5. I'm going to skip the word problem in this section. So let's think about how to approach this problem. Step number 1, we want to get everything equal to 0. We are solving this polynomial to the 5th power. Okay, we're not used to doing that. So let's make everything equal to 0 here. So we got 3x to the 5th, and then we're going to move this over on this side, so we're going to subtract it. So minus 18x cubed. Now we can still have plus 15x equals 0. Next, you notice 3, 18, 15. You can pull out a 3, and you can pull out x third x. You can pull out an x. So let's pull out a GCF at step 2. And we get x to the 4th here. We get minus 6x squared. Now we get plus 5 here equals 0. Now, the only way you know how to do this so far is to factor. So this thing has to factor. But it's x to the 4th power, x squared. Once again, if you get something like this, you want to think to yourself, is this thing in quadratic form? No, it's not a quadratic, but is it in that form? So here's what I do. Instead of x to the 4th, I say, well, x to the 4th is x squared squared. I'm making that a square. And then I say minus 6x squared plus 5. Okay, now look at that right there. This is where I see, notice these are the same. They have to be the same for me to do this next step. Instead of x squared, I'm going to say off to the side, u equals x squared. So instead of x squared, I'm going to put u. So I'm going to get u squared minus 6. Instead of x squared, I'm going to put u. And then I got plus 5. Now look at that. It's the same idea as before. This now looks like a quadratic, right? So let's factor it. U, let's see, factors of 5 add up to negative 6. So minus 5 and u minus 1. But u, remember, isn't really u. U is x squared. So we're going to have x squared minus 5 times x squared minus 1. Now we're missing something, right? We're missing the GCF up here, so don't ever forget that one. We got 3x times this times this. Still equals 0. Now you could factor this one more time, but in this case you really don't have to, because it doesn't ask for factoring. It just says what are the solutions. Now you remember zero product property. It says each of these things could be 0. A, B, or C could equal 0. So here's what you're going to do. You're going to say the first one, 3x could equal 0, or the next one, x squared minus 5 could equal 0, or the last one, x squared minus 1 could equal 0. That's the zero product property. Solve for the first one. This answer, divide by 3, x equals 0. Circle that one. That's part of our answer. Next one, plus 5, so x squared equals 5, which in turn, if you square root both sides, you get x equals plus or minus root 5. There is another answer. And lastly, plus 1, x squared equals 1. So x equals, if you square root both sides, plus or minus square root of 1 is just 1. There is your answer there. Now do you notice how many answers we have? We have 1, plus or minus makes 2 and 3, and then another plus or minus makes 4 and 5. We have 5 answers. Notice this. That was to the 5th power. That happens. If we add to the 4th power, we'd have 4 answers. Okay? So write your answers nice and neat. If you look up here, which one of those answers, all these 5 up here are your answers. Letter D. So we just use factoring to come up with, to help us find our solutions. So factoring and then the zero product property allowed us to find our solutions. Alright, let's try one. Okay, last problem. You guys can try number 1, or you can go straight to number 9 here, the second one here. So make it equal to 0, factor, do your thing, and then solve. Alright, so pause the video, do that, and then your answer is here. There's your answer. If you guys have any questions, please come see me. You guys know the drill, so I'm always here after school during activity period. Have a good day.